Hi guys, I thought I'd do another video a little bit about tubes and tube theory, kind of explain some things a little bit. No math, but some graphs. One that is not on here is a Class C amplifier. That's what the letters mean. Class A, AB1, AB2, and Class B. Mainly because I want to talk about audio amplifiers. This kind of goes in conjunction with the last video I did on the screen grid inversion tubes. I made mention a little bit and about, well, for one thing, I talked about them being in Class A most of the time, but they could be an AB1 or AB2. I since then tried to find or locate some schematics for that, and I do have one that's running in an AB situation. It may be AB1, it's definitely AB, but I'll lay it down here and see if we can zoom in on it a little bit. Give me a second here. I can turn it down. Okay. Now, scoot over here. This is using 242s. Which are, I believe, 6K6. Don't remember. Now, the 41s are 6F6s, and I believe these are like 6K6s, just slightly a little different. But these two, I did a little bit of math on the their biasing, and which comes from the power supply here, right down in here. They're pulling bias off this line right here, so they had a voltage and resistance here, so I could actually figure out how much current goes through here, and that's the same amount of current that's pulling through these back to here through these resistors. And it works out that these are running about, I think it's minus 20 or minus 24, something like that. But in any case, it throws them outside the Class A range. It throws them in an AB range. Now, I did not work out the math for, or work out the for the driver, First Audio. It's running at 100 volts, which may be not quite enough to actually drive these to be AB2, so they may be running an AB1, but I'm not sure. Yeah, it's probably running about -2 volts on it. Let's see, that's a 6Q7. It may get there, that we could actually get it. I'll get to in a moment the difference between AB1 and AB2, why I'm talking about this, but this may have enough drive to run these into AB2 range, but they're definitely biased in AB for sure. They're not in the A range. So anyway, there's a schematic of a particular radio. It's a the Philco 4215 or 217. Both models are on this schematic. So anyway, now back to what we're going to talk about. Back out. There we go. Alright. Most of the amplifiers you run into, especially in receivers, will be, whether they're push-pull or not, if there's, well, definitely if they're single-ended they'll be, but even if they're push-pull, the vast majority, close to 80%, will be Class A. Now there's a reason for that. Now, and I'll get to it in a minute. One thing about Class A, the tube works all the time, so it's the least efficient of amplifiers because the tube's always drawing current. It's always turned on. So that makes it the least efficient. But why it's used so much is because this curve right here, which is the grid curve, this represents the grid to plate current. That's what this is here. Right down the bottom is your grid voltage. Negative over here, positive over here, 0 in the center. And the line going up is the plate current. And this line will represent, and it'll be different for different tubes, but it represents the grid voltage to plate current curve. So there is a portion of it that is a straight line. Now my drawing is not the grandest, but it is pretty darn straight, and they call it the linear portion. If you operate a tube in that linear portion, then you get the best fidelity, the least amount of distortion. So Class A actually picks an operating point. This is your zero signal operating point. This is where your bias will be at with no signal going into the tube. And it is usually, it'll be picked so it's centered along this. Now it don't have to be, because actually the definition of Class A means that the plate is operating completely all the time. With the signal going in, I will get a representation, amplified representation of the input signal all the way through the entire cycle. That is Class A. So I can actually move that point anywhere as long as I don't clip off down here or up here. This is saturation point, the maximum amount of current the tube can produce or flow through it. So if I don't go at either one of those points, as long as I keep this point here so that that signal at its maximum strength will keep this curve in between here and here, I'm fine. It's Class A. But if you're designing one and wanting to have it operate with the least amount of distortion, you center your operating point on the linear portion. And except for the very strongest signals, it will operate with virtually no distortion whatsoever. Now it can get down in the what they call the knees, the bends of the curve, and that's where you start getting your distortion from. But that's Class A. It's the least efficient. It is also the least powerful. It's not going to amplify them. It's the least on an amplification range. So it has the least gain. They still amplify really good, but of all the amps that I got represented here, it's the lowest power output. But it's got the best fidelity output because it has the least amount of distortion out. The opposite end of that is Class B, right here. Just a second here. My camera's being stupid. Anyway, your opposite end is Class B. Now Class B, you set your operating point at cutoff. So when no signal's going through, the negative bias on your grid will be at cutoff, where the tube goes in cutoff. So no current goes through the tube at all. So as long as there's no signal, the tube does not at all operate. And the only time that tube has any power or any operation, any current going through it, is when the signal is going positive and it pushes the grid positive above the cutoff range. On this side where the signal's going negative, nothing happens. It's going further into the cutoff region. And at 0, it's in cutoff. So only here, this portion here, where the signal goes positive, is that we get an output. That's only when the tube is operating. The thing is, since it's so far down the curve, it's right down at the bottom down here, we can actually get the greatest amount of gain, amplification. So these Class B will put out the most power of any of the other classes. But it's also, not only is it operating along the linear path, but it's also operating in this knee right down in here, which is a pretty good curve, and that produces considerable amount of distortion. So it distorts the worst. Another disadvantage of Class B is it'll distort really bad if one tube or the other tube starts weakening or aging differently than the other tube, or any of the circuits to it, any of the components, resistors or anything in each of the sections of each tube's individual circuitry. If they change value or anything, these will change the output of one tube versus the other one, and they won't be equal anymore, and it'll be enough that the audio output transformer can't keep up with it, so it will distort the worst on that situation as well. So with Class B, you want to keep everything as equal as possible, the tubes as matched as possible as far as their gain, and as well as, you know, all the other circuit components being matched as close as possible. Now they do make newer tubes were made that was called sharp cutoff tubes. Now some of them are used only for RF and stuff like that, so they're not audio tubes, but they started making some sharp cutoff or what they call super sharp cutoff tubes for audio, for explicitly for Class B, which don't have near as much bend down here, so it allowed the designers to be able to use those, and they could actually get a little bit out of whack or something and still operate perfectly fine with the not as much distortion. So in between these two, we have Class AB. Now we're going to come back to this here in a minute, but with Class AB, and I think, yeah, I got pretty much all of it on here. You got, and it's broken down in two sections. You got AB1 and AB2. AB1 is, in both of them I set the operating point somewhere between cutoff and the linear portion, center point anyway, basically between A and B, so that's why we call them AB. They operate with it being in there, then I not only get my full positive or going signal amplified, but I get a portion of the negative as well operating, although it does get cut off a little bit. But the crossover, what is known as the crossover between when you run push-pull, this takes care of any problems that you would have in a Class B with crossover, because they overlap just like Class A does, which overlaps completely. So these have less distortion. They also operate a little bit up. They're in the bend of the knee, but they're not as bad in it as with it having down in the cutoff region, where all of the amplification will be in here, and low volume and even high volume you're going to have a lot of stuff going on down here. So they don't distort as bad, but they're less efficient than Class B because we're operating about more than half less than full time. The only difference between Class AB1 and Class AB2 is the fact on AB2 I push at the strongest signal, or when my signal gets strong enough, I push the grid positive. I have some grid current and I allow my grid to go positive. Now that can be accomplished a couple different ways by moving the operating point just right and setting up and using the right type of tubes. I can do that. Or I can have actually the same operating point, in other words the same negative voltage, but, and this is what I was talking about the preamp tube on that schematic, is does it have the range to do it? If it's putting out a strong enough signal, peak to peak, coming out of it at a high, when you adjust the volume level up, that can push this grid to positive, then the output is running AB2. The only thing is, and this one really, to get the maximum gain out of a Class B, we actually do run the grid a little positive on it too, on the positive peaks. So on both of these, there's going to be points when we do have some grid current. We got to get it from somewhere. So one of the problems is where to get it from. Well, the early days of radio, which when they had push-pull, they actually ran Class B quite a bit. It was no big deal because transformers were cheap. Iron was cheap. So they just put an interstage audio transformer, a transformer between the preamp first audio and the push-pull output tubes. So you just put a transformer in there. It's no big deal. You can get current out of that because it's just it's magnetically coupled. As the transformer operates, transformer action will put current in that secondary, and if you want it, it's there. But then iron got expensive, depression came on and stuff, so some other means had to be figured out. And for those companies that still wanted to keep using Class B and they didn't want to pay for the transformers, then what they did, they had to do some elaborate circuit work on the first audio or the input audio into that push-pull, and they either pulled current off the plate circuit, which meant you didn't have a coupling cap, and you can do that. At some point I may draw up how you can do that in a future video. Or you can pull it off the cathode by putting a voltage divider in there, and you can pull some current out from there and feed it. You can also have, if you pull it off the cathode, you don't have any gain from that first audio, but you can always put a tube before it to give you some more gain. Amplify it, run it through that cathode follower is what they call them. Run it through there and then get your current you need for the AB1 or the B. So that's another way of doing it. But there's a third way of doing it, and that's fixed bias. Just like I showed you on this schematic here, if I can hold this steady, that's what this is fixed bias. We put this voltage divider, it goes to ground here, but we put this voltage divider in the center tap, on the center tap of the secondary, high voltage secondary. Normally this would go to ground. In most radios it does, but on this one it goes through this, and this is to pick up various negative grid bias voltages, and this is called fixed bias. Thing is, I got a lot of current going through here. All the current that goes through B plus goes through here. So I got ample current I can pull current from. So fixed bias is another way of doing it. Of course, if you got a battery operated set, you can also pull it off the C battery and just pull some current off of it. That's another form of fixed bias, except it's battery. But in those sets with fixed bias, that's got a power supply and the transformer and stuff, they'd set that up with that voltage divider, and then they had ample current when they needed it. So when this went into here on AB2, where the grid started going positive, strong enough signal to drive it positive, or class B, running it a little bit current on the grid, run the grid a little positive, no problem. Pull it right from that fixed bias point, and it will not affect the radio, will not affect the power supply. Everything's perfectly fine, and that's the least costly, because you're already figuring on you're going to have that in there to get your biases for different points. That bias is not, that voltage divider is not just strictly for the output tubes or audio. It is applying bias for the diode detectors. It's biasing those as well as the front end on that particular radio especially. So it's used for different biasing of different tubes throughout the radio. So it's already there. This way you can make use of it. So I really don't have much more to say about this. I didn't want to get too deep into it, because at some point this fall I'm going to do a series on actually just building, you know, talking about how to build a audio amplifier, what parts you need, how do you figure them, how do you, all this, and we'll have math in it. So the ones that don't like math, that it's going to have math in it. You can't design something without math. So, but those, I know there's been some that's been asking me about it, wanting me to get into that. So we will look forward to it sometime later this fall, some point. But the biggest thing I wanted to just show the four main ones. Again, Class C, which is generally used in receivers for the oscillator circuit. You would actually bias over in here, this point. In other words, the little green dot would be over here, and so the grid, except when it just a little bit of it going positive, when it's going strong enough positive, would actually turn the tube on. So you don't, of course that's the most efficient way, but that's all it's needed for an oscillator. Like I explained before, an oscillator, think of it like you're got a parent pushing a kid on a swing. Once they get them to where they want them at, they don't want to go any higher, then all they got to do is just give it a little shove every once in a while. Well, that's what happens with the tube and the oscillator. It just gives a little shove once in a while, and the way you design that is just bias the thing extremely negative, so that only the highest peak going positive will be a little bit of output from the tube, which gives that little push. But I just want to talk about the basic differences and how we can get some grid current, various different ways of doing it, and talk about the different fidelity and distortions. I didn't go deep into distortion. There's a lot of formulas for distortion, both even and odd harmonic. One thing I do want to point out, that a good operating push-pull amplifier, no matter what class it's in, has almost no even distortion, even harmonic distortion, because the output transformer cancels it out. It will cancel when it hits that the primary of the output transformer. So there is no even. Now, when I talked about that previous radio, one thing I did mention in there, that those only work with pentodes. You can put beam power tubes in those circuits, such as like a 6V6. You can put them in there, but all you end up with is basically a single-ended audio output, audio amplifier, because it don't have no push-pull really. Because on beam power tubes, there's virtually no current to speak of on the screen grids, and with no current I can't get no voltage. No voltage, I can't control the grid of the other tube. So it just basically kind of floats in there. Only one tube, the one that's getting the primary input, is the tube it's amplifying, and on those you will find even harmonics, because you're only using one side, 1/2 the audio transformer, primary. But if you're using, the pentodes in that circuit, then it won't have any even harmonic, or very little anyway, depending on how good the audio output transformer is and stuff. How well it's matched, everything's matched and everything. And I'm not talking about tube matching. When I get in audio amplifiers, we're going to talk about tube matching. But in any case, again, best fidelity, least efficient, Class A. Probably the least amount of fidelity, the greatest amount of distortion, but the most efficient, Class B. In between, AB. If it runs some current on the grid, it's AB2. If it never runs grid current, grid never goes positive, it's AB1. So, I hope if anybody had any questions, I hope that answers them. Again, in the fall, we'll go a lot more deeper into this, and we'll work out some design specs maybe for a couple different audio amplifiers. I don't know how deep I'll go into it, because the big problem is if I go real deep into it and say, well, let's use these tubes and this transformer and this and that, then there'll be some people out there who'll be trying to find those and not be able to find them for a reasonable price, blah blah blah. So, but we'll go through the basic math and what you need, and if you watch the series and pay, take some notes and stuff, you'll be able to design your own amplifier with whatever tubes you want to use and whatever components you want to use. I will put up links in those videos as we go through it on that series to different places to get stuff too. So anyway, that's basically it on this. Just to touch on these classes and just real simple basics. So I want to thank you for watching. If you like this video, give it a big thumbs up. If you're new to my channel and you like videos on electronic theory, especially tube theory, or as well as I do restorations on radios and TVs and stuff, and I do videos on that, then subscribe and you'll be getting notifications every time a new video comes out for me. I want to thank everybody for commenting on the last video. You guys had, you always have great comments. I really do feel like I got the best viewers on YouTube. So you're all great, and I thank you very much for watching and supporting me and putting up with my mistakes, which I had one on the last video on the placement of where I pulled the capacitor for the input of the second tube. It should have been above the resistor. It was at B+. So anyway, I had one viewer that noticed that, and I told him, yep, he was right, and I did make mistakes. So you guys seem to put up with my mistakes. So anyway, with no further ado, I think I'll go ahead and end this video here. It's a little shorter than usual, but I guess I'll see you guys in the next video. Thanks again for watching.